In this video, I'm going to show you how I make my own fixtures to be able to machine the turbine housings. This can also work for compressor housings, depending on how the part needs to be mounted. For the turbine housings, I usually have to make a plate, but not always. If I can grab it on the inside or the outside of the turbine housing, I'll surface the inside to grab it that way. But with this housing, it's made differently, and the only way that I can grab this is if I have a pie chuck or if I had a two-jaw chuck, which I don't have either one of those. For this one, I just have to make a plate and surface it out. So that takes quite a bit of time. It took me pretty much all day to do that. It's now 2 a.m. in the morning. I started this after church about 2 o'clock. These two pieces of metal have to be welded together, and it has to be mounted on the machine when welded. The reason for that is so that I can get it centered up with the center of the tailstock, so that the steel piece of round will be in as close to center as possible. That way I can machine it down, and it makes it so much easier when I go to line it up. This fixture will be completely adjustable from side to side. However, the face of it will get surfaced out so that will be completely flat, so there isn't not going to be any adjustment there. I noticed after I made this plate and mounted the turbine housing to the machine, I ran into a problem where the turbine housing itself was not perfectly flat. So I had to take the turbine housing off the plate and then machine the turbine housing flat so that I could mount it to the plate and it would be in symmetry. The turbine housing flatness was off on the Z dimension by 17 thousandths. Usually if it was off by 5, I would just surface it out, but since it was so far off, I had to go back and correct it before I could surface it out, because if I surfaced it out, it would move in the cartridge farther than I would like it to be if I was doing a surface job like that. If I surface it out 17 thousandths in depth, that makes the turbine wheel 17 thousandths deeper into the turbine housing, and that usually puts the turbine wheel inducer blade 17 thousandths more out of the flow stream and can hurt performance. The steel round that I use for this job I buy from metalsdepot.com. It's 2 inches of steel round. The plate that I used, I get a square plate that is 1/4 inch thick, and I get that from metalsdepot.com also. Then I just cut out my shape and drill the bolt holes of the plate. The steel round I put in the chuck and I turn it down and drill a pilot hole in the back side of it so I could use the center to be able to center it up when I go to, right before I go to weld it. The welder that I use for this job is a Miller-Matic 211. In this job I use a 110 plug on it, and I put the settings right below 3/8 to be able to weld the pipe to the plate. I didn't completely max it out because it's on the 110 power, but it does completely perfect like this. I prefer to use 220 when I can. I just don't have a 220 plug near the lathe. Here's the turbine housing after I did the machine job. It only takes about 30 minutes to an hour to get the turbine housing machined, but to make the plate and the pipe and then to put it all together and weld it, that's what took most of my time. That probably took me about 6 hours just to make the plate with the pipe welded on it. And then it was mainly because I had to make everything all from scratch. The pipe I had to cut down and then cut off to size. And then the plate I had to cut out with a torch and then drill the holes and then adjust the holes. This turbine housing was from a Precision Turbo upgrade. I think it's for a Supra. It looks similar to a CT26 turbine housing. This one, I don't know what it was originally machined for. I guess it was like a 60mm turbine. I took it and I machined it out to a PT 66mm turbine. So now this guy can build a 67, 66 for this. He could do a 64, 66 or a 62, 66. All those would be really good options for the Toyota Supra. For this one, what made it so hard was the fact that, or time consuming, was because the turbine housing wasn't surfaced out. That cost me probably about an hour and a half because I had already lined it up and then surfaced out the plate and then realized that it was off by 17 thousandths. Then I had to take it all back off and resurface the turbine housing on the outlet flange so that it would be flat when mounted to the plate. When I did that, I got it from originally a 17, I got it down to 3. So that's a whole lot better than 17. I didn't really feel comfortable machining it, even though I could have surfaced it out and I could have made it look right, but I didn't want to do that because it's just not really the way to build that turbo. It's best to just do it right the first time. If I was to just machine it the way that it was, then it would make the turbine wheel deeper into the turbine housing than needed to be. And when that happens, usually I have a lot of extra material I have to pour it out by hand, and I didn't want to have to go through that either because it just takes so much more time. Just trying to take a shortcut ends up taking you a lot longer to be able to get the project done. I spent probably about 6 hours making the plate because I had to make all those from scratch. The plate was originally a square 1 foot by 1 foot, 1/4 inch piece of steel, and then the steel round is just some steel round that I had laying around. And so it's just a thick, solid, round piece of metal I had to surface down and then cut it off. So I hope you guys learned something on how to make your own tools for machining housings. Now you can do the angled or like a housing that has an angle off of it. Those are a little bit harder, and when you go to do that, it has to be in symmetry when you go to mount it with the tailstock with the center, and you surface the pipe or the steel round there, and then the chucks have to be surfaced for that to come out in symmetry. So those are a little bit different, and it's a little bit more challenging to get that right, but it is possible to do it, and I've done it before. Anyway, thanks for watching this video, and if you want to watch more videos about turbo repair, you can subscribe to this channel.